Hey guys, welcome to my channel Subhas classes. Today we are going to continue from where we left in class 11 physics. We were studying unit and dimension. We have already covered standard international units, and today we shall start with the supplementary units. What are the supplementary units? The measurement of plane angle and solid angle. How can we measure them? There are two different kind of angles. The angle plane angle it is measured between 2 points on a plane connected to a point, and if these two are two rays, then this is the plane angle, and this is measured in radians. And you know from your 10th class that if it is the arc L and this is the radius of a circle R, then theta is equal to L upon R. So how can we find 1 radian? 1 radian will be found when both L and R have the same value, same length. So if we take the radius equal to length of arc of any circle, suppose there is a circle and its radius is 10 centimeter. So we take 10 centimeter upon the arc up to this point and connect the point. Then this angle has to be 1 radian because L upon R is 1. So 1 radian comes when L is equal to R, and that is equal to L upon R when length of L is equal to length of R. And how to measure this value? If we take the whole lot, the total circumference, which is 2 pi r, then what is the total angle? This angle should be L upon R, means 2 pi upon R. We get 2 pi radians. So the angle around a point connected to a plane, related to a plane, will be 2 pi radians. So how much is 2 pi radians? 2 pi radians in degrees is 360 degree. So we get pi radian is equal to 360 degree. So how much will be 1 radian? 1 radian will be 360 upon pi. So pi radian is 360 degree by 2, which is 180 degree, sorry. So 1 radian will be 180 upon pi, and if we take the value of pi to be 3.14, then we get 1 radian is equal to 180 upon 3.14, so which is nearly equal to 57.1 degrees. So this is how we decide the value of a radian. So the unit is radian. Next comes the solid angle. Solid angle is measured in steradians. This is radian and this is steradian. And for measuring the steradian, measuring the solid angle between 2 points, that should be a rotating point. So this angle, this solid angle, is, if it is d omega, a smaller value of omega, then if this length is, say, if this surface area is ds and this length is r, this radius is r, then the solid angle d omega will be given by the surface divided by square of the radius. From this we can calculate ds is equal to d omega into r square, or d omega is equal to ds by r square. This is of a prominent importance while we deal with flux, we deal with your Gauss law. In Gauss law this is used. So now we have got two formulae. For plane angle theta we have L by R, and for solid angle omega we get S by R square. In calculus form we can take this as dl by dr or dl by r simply, while for d omega we can take d omega is equal to ds by r square, and we can take here d theta is equal to dl by r. When this distance is taken as dl and this radius is r, this angle is d theta, and when there is a surface of area ds and it is connected to a point, then this solid angle d omega will be related to ds and square of the radius, ds by r square. This concludes the supplementary units. Now let us go for the prefixes. What are prefixes? In physics, while we measure things, sometimes we measure very small minute things, and sometimes we calculate very large things. When we are talking of mass of a rabbit, mass of a goat, it can be just taken in kilograms. But what if we are talking of an elephant? Its mass cannot be measured in kilograms. It will be large number of kgs, sometimes 4000 kgs, 5000 kgs, 7000 kgs. So here we use metric ton for larger values. So the prefixes that we use from larger to smaller in the descending order, we can take the value, for example 10 to the power 18, for which the symbol is E or exa. For the values like 10 to the power 15, we take P, that is peta. For 10 to the power 12, we take T, which is tera. For values like 10 to the power 9, we take N, G, giga. So these are the larger values for which we take the symbols in as capital letters. But when smaller values are taken, another thing, 10 to the power 6 is also written as mega, and the other values will be taken in smaller values. 10 cube is kilo, small k. Then your deci, 10 to the power minus 1, then centi for 10 to the power minus 2, then m for milli, that is 10 to the power minus 3, then mu, micro for 10 to the power minus 6, then 10 to the power minus 9, which is for nano, small n, and 10 to the power minus 12 for pico. How do we use them? If I have written 1 nanometer, radius of an atom is 1 nanometer, then this is equal to 10 to the power minus 9 meter. If the distance between two stars is 10 to the power 12 meters, then it will be written as 1 terameter. So this is the use of the larger things. The smaller values are also there. There are some shorter values, we can use them. One is femto or Fermi or femto. Fermi is taken as 10 to the power minus 13, femto is taken as 10 to the power minus 15, atto is taken as 10 to the minus 18, but they have a very rare uses. There are some shorter versions also for measuring the distance, atomic distances. We take angstrom, which is 10 to the minus 10 meters, and femtometer as 10 to the minus 15 meter. These are the shorter values. And for larger distances, measurement of short distances, while measuring short distances we are using angstrom or femtometer, but while measuring large distances we take some other values. Those values are astronomical unit. Astronomical unit is the, suppose the earth is revolving around the sun, it is using different orbits. The radius of the orbit is larger sometimes and smaller sometimes. If the mean orbital radius is taken and the main orbital radius is here, then the distance of the sun and moon in average, this will be taken as the value is 1.496 into 10 to the 11 meters. This is the astronomical unit. Generally the mean distance between the earth and the sun, this is taken as a unit. If we go for Alpha Centauri or Proxima Centauri, then the distance can be measured in terms of astronomical units. We are not using a measuring tape for measuring the distance between two stars. And the next larger unit is light year. Light year is the distance which light, the velocity of light is a very larger one. It is 3 into 10 to the 8 meter per second. So how long will light travel in a year? The year consists of 365 days. Each day is 24 hours. Each hour is 60 minutes. Each minute is 60 seconds. So if you multiply, there is a year consisting of 365 days and each day consisting of 24 hours. Each hour having 60 minutes or 3600 seconds. So you have to multiply 365 into 24 for days and 60 into 60 for minute up to second. In a second light goes 3 into 10 to the 8 meter per second. So this number of meter will be our light year, and compressing this and converting it to a single value, this will be equal to 9.46 into 10 to the 15 meters. It is a still larger value. And the third type of value is known as parsec or parallactic seconds. What is one parsec? When we are taking the mean distance between the earth and sun, suppose this is we are taking one astronomical unit here, and a distant star measures 1 parsec, 1 second. So if the angle subtended is 1 second of arc, and this is 1 astronomical unit, then the distance where this will form 1 second will be called 1 parsec, and this is generally 3.08 into 10 to the 16 meters, the largest of the units we use while measuring anything. So this is about the prefixes, the short measurements and the larger distance measurements. Then we talk about measurement of lengths by different scales. In physics we we use three different kinds of measuring scales. One is a scale you might have seen, which is a rectangular one having graduations here, and the maximum length that you can measure and the minimum distance that you can measure. This is the range of an instrument, and this instrument has to be calculated. This is known as a meter scale. And the meter scale can measure up to 1/10 of a centimeter or 1 millimeter. So the smallest value that we can measure is 10 to the power minus 3 meter, and the maximum distance we can measure is 1 meter. So up to 1 meter. So 1 meter is 10 square centimeter. So the value is 10 square. Say we can go up to 100 meters, and the minimum value is 10 to the minus 3 meter. So 10 square to 10 to the minus 3 or 10 to the minus 3 meter to 10 square meter is the range which a meter scale, ordinary meter scale, can be used for. The second kind is known as vernier calipers. Caliper, you know, there is an instrument in which you have one option to change the measuring positions. You have seen slide calipers, and you have seen screw gauge, spherometer. There are three different kind of instrumental experiments in your physics in class 11. So the vernier calipers has a range of measuring very small lengths like 10 to the minus 4 meter, and the other kind where you measure the diameter of smaller things like a cycle ball, diameter of a cycle ball, a motorcycle ball, a very small sphere. Then you use screw gauge or spherometers, and the range of measurement for these instruments is as less as 10 to the minus 5 meter. So just you can remember that the smallest distance a meter scale can use is 10 to the minus 3 meter, a vernier calipers can do is 10 to the minus 4 meter, and a screw gauge or a spherometer can reach is 10 to the minus 5 meter. So negative 3, 4, 5. Just one more questions. So remember this. Next we go for measuring of distances when it is a distance in the sky. So distance between the moon, or distance between Jupiter and Saturn, distance between Alpha Centauri and Proxima Centauri. So when measurements are very large distances, sometimes we go to suppose you are measuring, there are two different kind of measurements. I am going to measure the distance of a star from Earth. So I will take the two diametrical positions of Earth, so that this distance I know is the diameter of Earth. From class 10 you might have heard that the Earth's radius is 6380 kilometers, 6380000 meters. So you can see this is 6.38 into 10 to the 6 meters. This is the radius. So diameter will be twice that. This will be 12.76 into 10 to the 6 meters, and in scientific notations this should be equal to 1.276 into 10 to the 7 meters. So diameter of Earth is 1.276 into 10 to the 7 meters. This is a data for our future uses. And when I just connect these 2 points to a distant star, I get an angle. If this angle is alpha and this distance is small d and this distance is d, then I have a formula for plane angle. Theta is equal to L upon R. Here the alpha vector, alpha will be d upon d. So d will be alpha into d. If we know alpha and d, L upon R, d upon d is alpha. So if we know the distance, the diameter of something, then we can find this distance, or if we know this distance and this, we can find this. So this can be used to find the diameter of a distant star also, diameter of moon for example, and from two different locations of earth, diametrical opposite points, if we measure here there is moon, we can find the distance of moon from earth by this method. So this is a method used. This method is known as parallax method. I just give you an example how we use this method. What is parallax? Parallax is the apparent shift of a position when viewed from two different places. Suppose I see an object here. Suppose there is an object here. When I see that there is a object behind it, this one. But when I see the same object, the position will shift to some other place. See. So when I am shifting my position, the background or the surrounding of this object is changing from this to that. When I change from this to that, my surrounding or background of the object changes from this to that. This is an apparent shift. So this method, this has a link with this and this. This method is known as parallax method, and the parallax method is used for two different purposes: finding distance between 2 points, suppose there are 2 points A and B. I need to calculate the distance between 2 points A and B, which is small b, and I have an angle here theta, and if I know that this distance is d, this distance is d, then I use the method theta is equal to b upon d, from which I can find b is equal to d theta, and here theta is taken in radians. This is one use. The second is diameter of a star. In this case, we take two different positions. We measure the same from two different. Suppose the star is here. The diametrical opposite points are measured from a point. Suppose on earth we are here. I want to measure the diameter of the star. So I will take the value, this value and that value, and this is the diameter of a star. If the diameter of a star is d and this distance is capital D, then this angle is alpha. I measure alpha and I have this d, then I can measure this. So in this method we can say alpha is equal to d upon d, so that d is equal to d into alpha. This method can also be employed for measuring the diameter of a distant star. Now let us go for two numerical problems what we just studied. The two numerical problems concern the value of radian, how to convert one say degree, 1 minute and 1 second into radian measure. This is the first problem. We know that 360 degree is equal to 2 pi radians. and this we can write as 2 pi for a circular measure sine 2 pi c. 360 degree is 2 pi c. So 1 degree will be 2 pi upon 360. This will be pi upon 180, and we can use the value of 3.14 and divide it by 180 to get this result. We can take the use of a calculator to find this one. So degree is measured like this. So we remember 1 degree is equal to pi upon 180, pi upon 180. Next, one minute. What is 1 minute? 1 degree is equal to 60 minutes, which is equal to pi by 180 radians. So how much will be 1 degree is equal to 60 minutes. A single dash is taken. So 60 minutes is pi c by 180 and pi by 180, and 1 minute will be pi radian divided by 180 into 60. So this can be found by using 3.14 divided by 1810800, this value. So 1 minute is pi divided by 10800 number of radians. And if we want to just convert 1 second of arc, what is 1 second of arc? 1 degree is 60 minutes and 1 minute is 60 seconds, and this 60 seconds measure pi upon 10,800 radians. So how much will be 1 second of arc? That will be pi radians divided by 10,800 into 60 again. So this will give you a very small value but a larger number on the 648 into 3 and 3 zeros, this value. So 1 second of work will be pi upon 648 000 radians. So if you use your calculator, you can find these 3 values, and this is the measurement of degree, minute and second in radians. You can be asked, find, there is a second question, find the diameter of the moon if when measured from two diametrically opposite points on earth subtends an angle say 1 degree 54 minutes. So what will be the diameter of moon? Clearly the moon's diameter we do not know, and this angle is 1 degree 54 minutes. The moon is here, the earth is here. This is the earth diameter which is known, and what is the earth's diameter? That is generally 2 into 6,380 kilometers. And in this class we have already found that to be 1.276 into 10 to the power 7 meters, because you know you can make this meters, then you get 1276 and 4 zeros, this much meter. And if you calculate by taking a scientific notation, for scientific notation you keep the value between 0 and 10, or 1 digit. So you have 7 points here. So this is 1.276 into 10 to the 7 meter. So here diameter of earth is 1.276 into 10 to the 7 meters, and this measure alpha is given as 1 degree 54 minutes. You know 1 degree is 60 minutes, so 60 plus 54, which is 114 minutes. So now you can find this is not the diameter, this is the distance, because if this is the diameter, this is the distance, and so distance of moon from earth when measured from two diametrical opposite points subtends an angle 1 degree 54 minutes. So if I take this to be d, then I know that this small distance is d. So d is equal to we have alpha is equal to d upon d. So d is equal to alpha into d. So I use 114 minutes, and that has to be turned into radians. How to find them? Just a few minutes ago we have studied that this is 1 degree is pi upon 180 radians, and this is pi by into 60, so 10800. So this is equal to 114 into pi by 10,800. This is the value which you, and when we find the distance, d upon d is alpha, so we can multiply d and small d. So we can multiply 114 into pi 3.14 divided by 10,800 into 1.276 into 10 to the 7 meters. So calculating this, we can find the final distance of the moon from the earth. With this we conclude this section of this chapter, and in the following chapter we are going for use of the units and dimensions in dimensional analysis. Till that, thanks for watching my class, and bye.